Yeah, so good evening. Good evening, everyone. Yeah, is it fine now? I think now it's fine. Is it fine now? Yeah, fine. Now, thank you. Thank you so much, everyone. Right, yesterday also some technical issue came. Now it's fine. Perfect. Yeah, let's move to the next. Let's move to the next. Yeah, it is the first problem. Can you go ahead? It's the first problem. Can you go ahead? Yeah, now check. What is the answer? Waiting for RIC on DA subjects. Yeah, Prasan, I think this week mostly will come. Mostly this week will come. Yeah, what is the answer for this? If G is a forest with n vertices and k components, how many edges does G have? Check what is the answer. If G is a forest with n vertices and k components, k connected components, then how many edges does G have? So what is the answer? What is the answer for this? So G has a forest with n vertices and k components. So see this one, k components. One component, another component, another component, another component. Some k components are there. K components are there. G having k components, right? So let's see numbers. I can give whatever order I want. 1, 2, 3, 4 and so on, k components. And one more thing is G is a forest, right? See this one, G is a forest. Now is there anyone who can help me? G is a forest. When you say forest, that means forest is a collection of trees. Forest is a collection of trees. See, disconnected graph is not forest. Disconnected graph is not forest. Disconnected graph different and forest is different. In the forest, whatever components are there, every one is a tree. In the forest, whatever components are there, every component is a tree. Some people are thinking that disconnected graph is a disconnected graph is a, some people are thinking like this one, disconnected graph is a forest. No, disconnected graph is not a forest, right? So disconnected graph where every subgraph is a tree. Disconnected graph where every subgraph is a tree. So remember, it is a tree. It is a tree. Cycle is not allowed. It is a tree. It is a tree. It is a tree. And let us assume that k components are there. So I think first of all, one node is there. So k nodes are went like this. K nodes are, because of k components, k nodes went. So total is n nodes, k nodes went. Remaining is n minus k nodes. Remaining is n minus k nodes. Suppose assume that if total nodes are 20, if the number of components are 5, 20 minus 5, so 15 nodes are available now. 15 nodes are available with us now. Now what you do is, for every, see this one, 15 nodes are available, every node one edge will come. Suppose if you take one node here, one edge will come. Because every component is a tree. If you take one more node here, one more edge will come. If you take one more node here, one more edge will come. If you take one more node here, one more edge. One more node, one more edge. One more node, one more edge. So you have n minus k vertices are there. So n minus k edges will come. N minus k vertices are there. N minus k edges are there, because every vertex will give one edge. Every vertex will give one edge. So he is asking, how many edges does G have? How many edges does G have? N minus k edges. N minus k edges G have. If n minus k is 15, 15 vertices are there. For every vertex, one edge will come. Sir, where should I keep those 15 vertices, sir? You keep in any tree. If you want, you can distribute also. If you want, you can distribute also. If you want, you can keep in any tree also. Sir, can I keep all these 15 in one tree, sir? Yes, you can keep. Sir, can I keep 15 in 15 people, sir? Yes, you can keep. But remember, every vertex will give, out of these 15, every vertex will give one edge. Every vertex will give one edge. Every vertex will give one edge. Answer is, I think, n minus k. Answer is, I think, n minus k. You have to understand only one thing, right? You have to understand only one thing. See this one. Collection of trees. Collection of trees is known as forest. Collection of trees is known as forest. So forest is a disconnected graph where more than one tree available. Forest is I am repeating once again. Forest is a disconnected graph where more than one tree there. I am writing that also. Forest is disconnected graph. Forest is disconnected graph where more than one tree exists. Forest is a disconnected graph where more than one tree exists. Please let me know if anyone having small doubt. G is a forest with n vertices and k connected components. K connected components. How many edges does G have? Yeah, can I move to next problem? Can I move to next problem? Can I move to next problem? Sir, if anyone says, sir, I have this doubt, you please let me know what is your doubt, I will help you. Sir, this is my doubt, sir. You ask me, I will help you. Sir, this is the doubt, sir. You ask me, I will help you. Right, perfect, perfect. Now let's go to next. Let's go to next. Yeah, what is the answer of this? Problem number 2. Any doubt there? Please let me know. Chromatic number of an n-vertex simple connected graph which does not contain any odd length cycle. Remember everyone, any graph which don't have odd length cycle, then it is a bipartite graph. Any graph which don't have odd length cycle, it is a bipartite graph. If any graph is a bipartite, odd length cycle is not exist. This is true in both the side. So I am repeating now. See this one. Odd length cycle not exist. Odd length cycle not exist. Then it is a bipartite. Right? Next one. Odd length cycle not exist. Then bipartite. And one more thing. If it is a bipartite, odd length cycle not exist. It is true both the side. Odd length cycle not exist. It is a bipartite. If it is a bipartite, odd length cycle not exist. Both the side it is true. What is the chromatic number of n-vertex simple connected graph which does not contain any odd length cycle? Where number of vertices are greater than or equal to 2, 2 or more than 2. Odd length cycle not exist. So what is the answer? If odd length cycle not exist, it is a bipartite. Bipartite means odd length cycle not exist. Then I think chromatic number of bipartite graph is 2. And one more thing, see this one, he said connected graph. If you want, you can see this one. He said connected graph. So it is also bipartite. See this one, it is also bipartite. Suppose assume that here vertices 1, 2, 3, here vertices 4, 5, 6. It is also bipartite, but it is not connected. So then chromatic number is going to be 1 only. C1 give. Then chromatic number is 1 only. So that is the reason he said connected. Where number of vertices are more than 2. Number of vertices are 2 or more than 2. That means at least one edge required. Then automatically two colors will come. Right? Bipartite means number of colors are 2 or 1. Because of he said connected. So 1 or 2 is the answer. Because of he said connected, so 1 is not possible. So 2. Because of connected, so right, if it's connected keyword is not there, 1 or 2. Because of connected, it became 2. Yeah, can I move to next problem? Someone is saying, Ahan is saying that, sir, please start from theory. Yeah, so next year I will start. Ahan, theory I will start next year. 2025 GATE examination, I will start theory. Right? Now only problems. Now only problems. Can we move to the next problem? Can we move to the next problem? Check if anyone having small doubt also. If anyone having small doubt also, please let me know. Right, perfect. Now go to the next problem. Which one of the following is true for any simple connected graph? Which one of the following is true for any simple connected undirected graph with more than 2 vertices? Which one of the following is true for any simple connected undirected graph with more than 2 vertices? Which one of the following is true for any simple connected undirected graph with more than 2 vertices? No two vertices have same degree. Remember, simple connected undirected graph. Simple connected undirected graph, more than 2 vertices. No two vertices have same degree. No two vertices have same degree. Many people can have same degree. So, one cannot be true. At least two vertices have same degree. At least two vertices have same degree. So, I think in this diagram, at least two are having same degree. Let me write one more. At least two having same degree. Let me write one more. At least two have same degree. Let me write this one. At least two have same degree. Next one. At least three vertices have same degree. Three people are having same degree. More than two vertices, okay. At least three people are having same degree. Two here. 2 here, 3 here. Suppose if I remove, at least 2 people are having same degree there. At least 3 not possible. All vertices having same degree. I think answer is 2. So you have to take some example and you have to check. You have to take examples and you have to check. So I'm again saying to you, 200 problems I am going to cover. 200 problems I am going to cover. See this one, class notes followed by PYQs followed by these 200 questions, please take care. These 200 questions, please take care. Maybe 100 to 200, I am not sure. It depending upon how many queries will come from your side. I will give, from my side, I am thinking that 100 to 200. If anyone having any doubt, you can post in our group. So if anyone is not there in the group, this is my WhatsApp number, you ping me, I will add you in the group. If anyone is not there in the group, this is my WhatsApp number, you ping me, I will add you in the group. In that group, you can post your doubts. In that group, you can post your doubts, I will resolve. So to this problem, answer is going to be second option. To this problem, answer is going to be second option, right? Take some examples and check. It is a very simple problem. Yeah, can you go to the next one? 3 problems are over. It is a fourth problem. It is a third problem. It is a fourth problem. Q4, question number 4. Yeah, try now. What is the answer? So, what are the chromatic number of following graphs? What are the chromatic number of following graphs? Some graphs are given, you have to give chromatic number. What is the answer? Two graphs are given, we have to find out chromatic number. Remember everyone, chromatic number means minimum number of colors. Chromatic number means minimum number of colors. Remember, this is a NP complete problem. Means there is no algorithm. This is the NP complete problem, there is no algorithm. NP complete problem, there is no algorithm. Chromatic number means minimum number of colors. Minimum number of colors to find out. There is no algorithm, so NP complete problem. So remember everyone, triangle will take three colors. Triangle will take three colors. Yeah, let me try this one. Triangle will take three colors. Let me try this one. C1 color here, C2 color here, C3 color here. There is no algorithm, manual checking only. So C1, C2, C3, because the triangle will take three colors, fine. Right? Let me be careful and give the answer. This one can be written as, I think C1, C3, it is the C2. Till now three colors. See, remember triangle will take three colors. And one more thing, there is no algorithm, manual checking only you can do. And one more, C2, C3, it is a C1. It is the C1. It is also C1. It is C2. I think to this one, three colors. I am very sure minimum three colors. Because the triangle there. Because of triangle there, minimum three colors. Can you explain difference between P, NPC, NPH? So it is not there in the syllabus. Rohit, it is not there in the syllabus. Right? So not required. Otherwise I could have covered. Someone is saying that, Saurabh is saying that 2 and 4. How 2, man? Whenever triangle there, how 2? Triangle there, let me write now. Triangle there. Three colors. Triangle there, three colors. Next one, one more thing. If max degree, if maximum degree is 5, then chromatic number will be, if the maximum degree is 5, chromatic number will be at most If maximum degree is 5, then chromatic number is at most 6. Triangle, 3 colors required. Next one, if maximum degree is 5, then chromatic number is at most 6. At most 6. At most 6. I am not saying exactly 6. At most 6. If maximum degree is 5, then chromatic number is at most 6. So if anyone having small doubt, can you see this? Can you see this one? 4 vertices are there, complete graph. 4 vertex complete graph. See this one. Maximum degree 3. 4 colors required. Complete graph. Complete graph. If maximum degree is 5, then chromatic number is at most 6. Example also I given. Check. Now come here now. First one, first diagram, chromatic number 3. First diagram, chromatic number is 3. And one more important thing is, first number is a planar graph. See this one. Every planar graph is 4 colorable. Means if the given graph is a planar graph, every planar graph is 4 colorable. Every planar graph is 4 colorable. That means at most 4 colors. Every planar graph is 4 colorable. Means at most 4 colors. At most 4 colors. At most 4 colors. Every planar graph is 4 colorable. Means at most 4 colors. So by seeing this problem I can say, listen, by seeing this problem I can say, can you help me? Now? I am just giving boundaries. What is the maximum degree? 6. If maximum degree is 6, right? At most, chromatic number at most 7. If the maximum degree is 6, chromatic number is at most 7. And one more thing is, it is a planar graph. At most 4. It is a planar graph. At most 4. Next one. There is a triangle. So every triangle is 3 colorable. So answer is for by seeing all of them I can say answer is at most 4, at least 3. So answer is 3 or 4. At most 4, right? Triangle means at least 3. So 3 or 4. I verified. So 3 is enough. 3 is enough. So in the similar way, can you go to the second part? What is the maximum degree? This is 4. What is the maximum degree? This is 3. What is the maximum degree? This is 4. What is the maximum degree? This is 4. What is the maximum degree? This is 4. 4 or 5? 4. What is the maximum degree? This is 4. I think maximum degree is 4. Maximum degree is 4. If the maximum degree is 4, right? At most 5 colors. At most 5 colors. At most 5 colors. If the maximum degree is 4, at most 5 colors, right? Let's check what is the answer. Please careful. And one more thing is triangle also there. So minimum 3 colors. Triangle also there. Minimum 3 colors. Because of maximum degree 4, right? At most 5 colors. Because of triangle there, minimum 3 colors. So answer is 3 to 5. 3 to 5. Let's check what is the answer. Yeah, I am giving the answer. See this one. It is the C1. It is the C2. It is the C3. C1, C2, C3. Three colors confirm. Till now, three colors okay. Yeah, next one. Next one. C2, C3 already there. It is a C1. Until now, three colors. C2, C1 already there. It is a C3. It is a C3. Right. So if I want to give C1 problem, if I want to give C3 problem, if I want to give C3 problem, can I give C2 here? Yeah, if anyone got more than 3, if anyone say 3 not possible, let me know. There is no algorithm, manual checking only. Manual checking only, there is no other way. Manual checking only, there is no other way. Right, perfect. So manual checking only. If anyone say less than 3 possible, less than 3, no way. Less than 3, no way. Yeah, move to next. Perfect. Move to next. Perfect. Now, and one more thing is I want to say to everyone, one more thing is, see this one, totally 12 subjects are there. Totally 12 subject. Every subject 100 to 200 problems I will cover. As many difficult problems as possible I will cover. 12 subjects total. Every subject 100 to 200 problems I will cover. Approximately 1500 to 2000 problems I am going to cover. Right, very serious one. Difficult questions and useful to exam. To show my greatness, I don't do unnecessary problems. To show my greatness, I don't do unnecessary problem. 1500 to 2000 of high quality questions will be solved. RIC for the GATE, right? GATE 2024. RIC for CSC GATE 2024. Approximately 1500 to 2000 questions I will solve. If anyone is not joined exam prep tool, right, you can join. Algorithm already done. DBMS is already done. Algorithm already done. DBMS is already done. TOC started. And now I started the discrete mathematics. Very soon we are starting digital also. Total 12 subjects will be covered. If anyone is not taking the subscription, you can go to exam prep tool, you can subscribe, or you can WhatsApp me, I will guide you. It's up to you. But one thing is it will be really useful to you. 1500 to 2000 questions of high quality. If you think that some difficult problem is not solved, we will solve that also. 12 subjects, every subject of 100 to 200 questions. If anyone is not joined, right, my suggestion is please go and join. That is my request to you. If you are serious about exam, you should join the RIC course, because we are keeping lot of efforts. We are not doing unnecessary problems. All the necessary problems we are covering. All the necessary problems we are covering. If anyone want good quality, and flawless problems, good quality, and one more thing is, right, there is no wrong in the any question or answer. If you want high quality questions of 1500 to 2000, my suggestion is you can join the RIC. Really, I am saying to you, I will do justification whatever amount you paid. It will be really useful to you. Let's come to question number 5. Yeah, it is a question number 5. Can you try now? Yeah, can you see this? In a simple undirected graph with n vertices, what is the maximum number of edges that you can keep the graph disconnected? In a simple undirected graph with n vertices, what is the maximum number of edges that you can have keeping the graph disconnected? N vertex graph disconnected, maximum edges how many can have? N vertex graph disconnected, maximum edges how many you can have? Gate exam is like that only. There is no difficult questions. Small twist will be there. Gate exam is in such a way that small twist will be there. Unnecessarily some people are taking so dangerous problem, they are keep on trying. Gate exam is not like that. Gate exam purpose is tricky questions. Some small tricky questions are there. Small tricky questions are there. So what is the answer? Small tricky questions. Very soon digital is starting. Now I started the discrete mathematics. Very soon digital will start. Right, very soon I will start the CN also. Very soon I will start CN also. CN and discrete mathematics I may do in the YouTube. CN and discrete mathematics I may do in the YouTube. Remaining subjects all are there in the EPT. If anyone not taken, please take, it will be useful. Yeah, now see everyone. Now see the interesting answer. Everyone listen. Interesting answer. In a simple undirected graph with n vertices, what is the maximum number of edges? That you can have keeping the graph disconnected. Now listen everyone. N vertices are there. Maximum number of edges are. N vertices are there. Maximum number of edges are Kn. N vertices are there. Maximum number of edges present in Kn. How many? N into n minus 1 by 2. N vertices are there. Maximum number of edges present in the Kn. Kn contain number of edges n into n minus 1 by 2. N into n minus 1 by 2. Now listen everyone. He is saying that graph is disconnected. Listen. He is saying that graph disconnected and you want more edges also. Then what you do is, this is the graph which is disconnected. Here n minus 1 vertices are there. Here only one vertex is there, disconnected. Here n minus 1 vertices are there. Here one vertex only there, disconnected. So n minus 1 vertices graph, maximum number of edges. What is the meaning? Kn minus 1. Kn minus 1 contain how many edges? N minus 1 into n minus 1 plus 1. Sorry, n minus 1 into n minus 2 by 2. Right? N minus 1 into n minus 2 by 2. So this is called as NC2. This is called as n minus 1 C2. This is called as n minus 1 C2. This is n minus 1 C2. In n vertices, maximum number of edges are kn, n into n minus 1 by 2. N into n minus 1 by 2 is known as nC2. Make tree and remove one edge. How yaar? How yaar? You want maximum edges. Maximum edges. Maximum edges. I think see this one. See this. See everyone now. 6 vertex. 6 vertex. Disconnected graph. Maximum edges how many? 6 vertex. Disconnected graph. Maximum edges how many? These are the answer. See, 5 people you take one group. 5 people you take one group. 1 person take outside. This is a complete graph. This is a complete graph. Right? So, answer is going to be 5 vertices, 5 vertices, 5 vertices number of edges K5, which is going to be 5 into 4 by 2. 5 into 4, 20 by 2, 10. It is the total is disconnected graph. Total is disconnected graph. You want maximum edges. Disconnected and maximum edges. Connected maximum n into n minus 1 by 2. Disconnected maximum 1 vertex keep outside. 1 vertex keep outside. One vertex keep outside. One vertex keep outside. Check if anyone, some people are asking, sir, why you kept one vertex only outside, sir? Why don't you keep more, sir? If I keep more vertices outside, then edges will be less. But you want more edges. If you want more edges, keep outside less people. You want more edges, keep outside less people. Because of disconnected, at least one I have to keep outside. Because of disconnected, at least one I have to keep outside. Because of disconnected, at least one vertex you have to keep outside. If you keep more vertices outside, then less edges will come. Bobby, that Rohit is that Gootle Rohit. Bobby, that Rohit is that Gootle Rohit. Bobby, that Rohit is that Gootle Rohit. He is Gootle Rohit. Arey Rohit, you are same Rohit. Oh my God. The person who spoiled my life. He came to EPT also. To spoil my life. Arey Rohit. Miss you, man. Rohit, miss you, man. Miss you. Arey, one dog is saying move to next problem. Arey Saurabh, if I give one kick on the nose will break 10 parts. If I give one kick on the nose will become 10 parts. Then you will go to next problem. Arey, we are talking seriously. You will say, go to next problem. We are talking seriously. He is saying go to next problem. If you like next problem that much, keep your daughter name next problem. Arey Saurabh, keep your daughter name next problem. Keep your daughter name next problem. Arey Gootle. Arey seriously we are discussing. Seriously we are discussing that Gootle is saying go to next problem. Keep your daughter name next problem. Your son name next problem. Your son name is next problem. Fine, perfect. In a simple undirected graph with n vertices, what is the maximum number of edges that you can have keeping the graph disconnected? Right, fine. Rohit will go everywhere where Sar goes. Arey Bhavi, I thought you came to class. I thought you came to class to study, to identify where is the Rohit, to identify where is Saurabh, to identify where is Subham, to identify every nonsense person. You are coming. You are coming to class to identify every nonsense person. Arey. Chalo, next problem. Yeah, fine. Go to the next one. Go to the next one. To the sixth problem. Can you check? So the problem with Bhavi is he will do everything. Lastly, he will say like Chitti or Bujji. He will say lastly, sorry sir. Bhavi will do whatever he want. Lastly, he will say sorry sir. Like Chitti or Bujji, he will say sorry sir. Yeah, Suprit is saying that boss is in full mode. Arey Suprit, do your business. Suprit, do your business. Don't keep finger in my business. Don't keep finger in my business. Boss, I am full mode. Boss is in full mode. Just do your business. Yeah, what is the answer for this problem? Yeah, what is the answer for this? Which statements are true? Yeah, now see, one time see. Everyone listen. Everyone listen. One time see. One time see. Very interesting problem. Very interesting problem. Please listen. Please listen, everyone. Very interesting problem. 6 vertices. Listen, 6 vertices. 6 vertices, one vertex this side, one vertex this side, one vertex this side, 5 vertices this side, 5 vertices this side, one vertex this side, 5 vertices this side. Can you see this? Totally 6 vertices, one vertex this side, 5 vertices this side. Yeah, one vertex this side, 5 vertices. Totally it is a disconnected graph. Listen, totally it is a disconnected graph. It is a disconnected graph. See, 6 vertex disconnected graph. These are the maximum edges possible. 6 vertex, listen everyone now. 6 vertex disconnected graph. Maximum edges how many? 5 into, right? 5 into 4 by 2. These are the maximum edges in the 6 vertex disconnected graph. To this particular one, if I add plus 1, compulsory connected. If I add plus 1, compulsory connected. So that's what you want to say to you. Out of n vertices, see this one. A simple graph is necessarily connected if number of edges are greater than n minus 1 into n minus 1. Remember, a simple graph with n vertices is connected if and only if, right, with n minus 1 vertices, these are the maximum number of edges, right? So comparing this one, edges are greater. What is the meaning? If one edge also extra more than this, compulsory connected. Compulsory connected. Can you help me now? 6 vertex graph, which is disconnected. Maximum number of edges are 10. If I add 10 plus 1, if I take more than 10 edges, number of edges are more than 10, compulsory connected. Will you agree or not? Compulsory connected. This is giving 10. If number of edges are more than 10, compulsory it is a connected. Compulsory connected. Someone is saying, will this video also be deleted? No, it will be there. No, discrete mathematics and CN, it will be there in the YouTube. Discrete mathematics and CN will be there in the YouTube. Remaining 10 subjects are there in the EPT. And one more thing, the videos which I do in the YouTube, I will delete unnecessary part, right? So only necessary part I will keep in the EPT. Right? Are you okay with this problem? A simple n vertex graph is necessarily connected if number of edges are more than this. See, more than this, number of edges are more than this means these are already maximum edges. If I add one more, compulsory, it is going to be connected. Thank you, boss. Tomorrow video where everything will be there in the YouTube, right? So discrete mathematics and CN will be there in the YouTube. Right, now come here now. A simple graph with n vertices and k components has at least n minus k edges. Now everyone listen. S2 statement. In the S2 statement, how many components are there? In the S2 statement, according to S2 statement, tomorrow's class, right? Sorry, yesterday's class is, I think, right, it is not started yet. Yesterday's class is some technical problem. I am unable to start. So today is the first class. A simple graph with n vertices and k components has at least n minus k edges. Now listen, S2 saying forest or simple graph. S2 saying, carefully read it, carefully read it, carefully read it. S2 saying simple graph or forest. S2 saying simple graph or forest. S2 is saying simple graph or forest. Simple graph. Simple graph n vertices k components has at least n minus k edges. Now listen. Now listen everyone. S2 saying that a simple graph, no forest here, a simple graph. S2 is saying that simple graph, not simple forest. S2 saying that simple graph which contain k components. Which contain k components. Right? K components are there. See this one, it is a component. K components are there. First component, second component, third component and so on. K components are there. K components are there. And one more thing is, listen, when you say component, listen everyone now, when you say component, component is a connected one. A maximal subgraph which is connected is known as component. Total n vertices, and k components is saying nowhere used forest, but k components. Remember, component is a connected graph. When you say it is a component, it is a connected graph. It is also connected graph. It is also connected. Remember everyone. It is a connected. It may have cycle also. It is a connected. It may have cycle, may not. It is a connected. It may have cycle, may not cycle. It may have cycle, may not cycle. So listen everyone now. Total is n vertices. Okay. So k components are there. So I think every k component means in everywhere one vertex. N minus k vertices are left out. If you keep one vertex in every component, n minus k vertices are left out. These n minus k vertices, every vertex will lead one edge or more than one edge. Every vertex will lead one edge or more than edge, because of it is not a forest. Cycle also allowed. Connected and cycle also means more edges also you can take. So if cycle is not allowed, n minus k edges will come. If cycle is not allowed, n minus k edges will come. Because of cycle also allowed, at least n minus k edges are allowed. At least n minus k edges are allowed. So what I want to say is, a simple graph with n vertices and k components has at least n minus k edges. At least n minus k edges, because n minus k people are left out. Because of k components, in every component keep 1 1. In every component keep 1 1. In every component keep 1 1. Okay. N minus k people are left out. Now for these n minus k people, for every person, either one edge will come, more will come. Suppose see this one vertex I kept, one edge came, one more vertex I kept, more than one edge also possible. So for every edge of n minus k, more than one edge also possible. N minus k people, everyone will bring one edge or more. So at least n minus k edges. At least n minus k, because cycle also allowed here. There is no forest. Suppose at least place if we say at most, wrong. At least place if we say at most, wrong. Because it is a simple graph, it is not a forest. Can you go previously? I think first problem maybe, let's see this. First problem maybe, let me read it. Let me read this one. I think this one. See this one. Listen, because of it is a forest. N minus k vertices are left out. Every vertex will bring one edge only. Exactly one edge. So, yeah, right? Then what is the answer? How many edges does G have? What is the answer? N minus k edges G have. Exactly, not less, not more. Exactly n minus k edges here, because here it is a forest. Cycle not allowed. And connected also, every component is connected. Every component is connected. And because of forest, no cycle also. So every vertex will give one edge only. Every vertex will give one edge only. See, new vertex came, one edge. 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 N minus k people, n minus k edges, exactly, not less, not more. But when you go to simple graph, right, minimum n minus k edges. Gate exam is basics only. Someone is saying that, sir, forest also simple graph. Remember, forest also simple graph, but every simple graph is not forest. Reverse not true. Reverse not true. Every forest is a simple graph, but every simple graph need not be a forest. Every simple graph need not be a forest. So I am repeating once again. Read nodes first, followed by P by Q, followed by RIC. This is the procedure which you have to follow. Read the nodes first, followed by P by Q, followed by RIC. Forest is a disconnected graph which don't have cycle. Forest is a disconnected graph which don't have cycle. But simple graph may be connected, may be disconnected, may be cycle, may not be cycle. Simple graph may be connected, may not be connected, may be cycle, may not be cycle. Yeah, come to this problem. Problem number 7. Problem number 7. Problem number 7. Yeah, can you go ahead? What is the answer? Yeah, what is the answer for this? Let G is equal to V comma E be a graph if S and T are two different trees with the sum of degrees in S is equal to sum of degrees in T. Then what is the relation between them? Now let's see this. Everyone listen. Everyone listen now. It is a G. It is a graph G. Graph G having, if S and T are two different trees, right? From the graph G, everyone listen. From the graph G, right? He took two trees. One tree is S. One more tree is T. From the given graph G, he took one subset, which is a tree S. He took one more subset or subgraph. From the given graph, he took two subgraph S and T, where S and T are trees. S and T are, right, subgraph and they are trees also. Subgraph and they are trees also. And one more, right? In this tree, sum of degrees is always even. Sum of degrees is, right, always even. Assume that it is 18. In this tree, sum of degrees are 18. In this tree also, sum of degrees are 18. Sum of degrees in S is equal to sum of degrees in T. So when you say sum of degrees, it is the 2 into E. So 2 into 9. It is also 2 into 9. From the given graph, you took two subgraph S and T, where S also tree, T also tree. Sum of degrees in S is 18, assume. Sum of degrees 18 means 2 into 9. Sum of degrees in T is also 18 because he said in the problem 18. 2 into 9. Listen, 2 into 9. I think this 9 is the number of edges. This 9 is the number of edges because it is the 2 into E. It is also 2 into E. So E is the number of edges. E is the number of edges. Now one small question I want to ask you. If E is the number of edges, see this one. Number of edges are 9 means vertices are 10 because it is a tree. In the tree, 9 edges are there means 10 vertices. It is also 10 vertices. So the number of vertices in S is equal to the number of vertices in T. I think this is correct. S means number of vertices. Cardinality, this is called cardinality. Size of S means number of edges. Cardinality of S means number of vertices. Mod operator means cardinality. Mod operator means cardinality. So Aman is saying something else. So can we go to next problem? Size of the graph means number of edges. Cardinality of the graph means number of vertices. This is called cardinality. Size of the graph means number of edges. Cardinality of the graph means number of vertices. So Aman asking something, listen, Aman asking something, everyone listen, n vertices are there, spanning tree contain how many edges? N vertices are there, Aman asking something, let me give answer. Aman asking something, let me give answer. N vertices are there, spanning tree contain how many edges? N vertices are there, spanning tree contain how many edges? Isn't that n value 5? 5 vertices are there, spanning tree contain 4 edges. N vertices are there, spanning tree contain n minus 1 edges, which is going to be 4 edges. 5 vertices means spanning tree contain 4 edges. Now listen, spanning tree contain 5 edges. Everyone listen, spanning tree contain 5 edges. 1, 2, 3, right? I think here 5 people. 4, so can you count how many? Can you count how many edges? 2 into n minus 1. 2 into n minus 1. 2 into n minus 1. 2 into 4, 8 edges. 2 into 4, 8 edges. So outside 5, inside 2, I think this. Now listen. Now listen one time. Listen. So careful. This is one spanning tree. So this is one spanning tree. This is one more spanning tree. This is one more spanning tree. Five plus 3, 8. So this is the one more spanning tree. Is it one more spanning tree? This is one spanning tree. This is one more spanning tree. So I am repeating once again. Graph contain 5 vertices. Spanning tree contain 4 edges. If at all, graph contain 5 vertices. Spanning tree contain 4 edges. Now original graph contain 8 edges. 2 into 4, 8. So 8 means 2 times 4. So 2 spanning trees possible. If 2 spanning trees are possible, that means to cover all the people, you have 2 paths. To cover all the people, you have 2 paths. One path is one spanning tree, one more path is another spanning tree. See this one. Like this also you can cover, like this also you can cover. That means, right? To make the any graph as disconnected, minimum 2 edges you have to remove. Because, right, if you delete one of them here, like this also you can cover, no problem. If you delete this edge, still graph is connected because there is one more spanning tree available. So minimum cut is 2. So I am repeating once again. So this is not your problem. Diksha, it is not your problem. Aman, you got. It is Aman problem. This is not yours, you people may not get. It is the Aman problem. What the Aman problem is, if graph contain n vertices, 2n minus 2 edges, if graph contain n vertices, 2n minus 2 edges, then minimum cut is 2 because 2 spanning trees are possible. Because graph contain n vertices, 2n minus 2 edges, that means you have 2 spanning trees. Means to cover all the people, 2 paths are possible. If you remove one of the graph, right, if you remove one of the edge, still it is not disconnected because another graph is there which will cover. This graph contain 2 spanning trees. It is not your, it is a Aman story. It is an Aman story, you may not get it. Leave this problem. If Aman get it is more than enough. It is the Aman story, you no need to bother. Right? Fine. Leave that one. Now come to problem number 8. Yeah, start now. What is the answer? Don't worry about the Aman doubt, you no need to bother. Yeah, it is a problem number 8. Let G be a complete undirected graph with 6 vertices. If vertices of G are labeled, then the number of distinct cycles of length 4 in G equal to. Graph contains 6 vertices. If vertices of G are labeled, then the number of distinct cycles of length 4 in G is equal to. It is a complete undirected graph. Remember, it is a 6 vertex complete undirected graph. 6 vertex undirected graph. And one more thing, complete graph. 6 vertex undirected and complete graph. Complete means every possible combination there. Every possible combination there. Every possible combination there. Yeah, 6 vertex, right? 6 vertex undirected graph. Every possible combination there. See, everyone degree 5. Now see what happened. Listen, he is asking in this graph, 6 vertex complete graph, how many, right? How many 4 length cycles possible? In 6 vertex graph, how many 4 length cycle possible? So what you do is, out of 6 vertices, first of all, select 4 vertices, 6C4 first. Out of 6 vertices, first to select 4 vertices. 6C4 ways are there. Next one, right? Now you selected the 4 people. With the 4 people, right? How many 4 length cycles possible? With the 4 people, how many 4 length cycles possible? Right? I will try one by one. I think, is it one 4 length cycle? See this one. Is it one 4 length cycle? 1, 2, 3, 4. It is a one 4 length cycle. So like that, how many 4 length cycles are there? We have to calculate. Now listen, out of 6 people, out of 6 vertices, I have to select 4 vertices first, because 4 length cycle there between 4 people. 4 length cycle there between 4 people. So out of 6 people, select 4 people first. 6C4 first. Now between 4 people, how many cycles are possible? And important thing is labels also there. A, B, C, D, E, F. Labels also there. I will give the labels once. Let us assume that out of 6 people selecting 4, 6C4, these many ways are there. Let us assume that those people are A, B, C, D. These are the people which I selected. Right? Out of 6 people, 4 people selecting 6C4 ways are there. Let us assume I selected A, B, C, D. Now A, B, C, D, see the cycle. See the cycle of A, B, C, D. A to B, B to C, C to D, D to A. So totally 4 edges. Right? A to B, B to C, C to D, D to A. And one more thing. Listen, one more thing. A, B, D, C, A. Right? One more thing. So I changed the C and D. One more thing. A, B, B already we done, I think so. Right? A, C, B, D, A. Next one. A, C, D, B, A. Next one. A, B over A, C also over. A, D, B, C, A, D, C, B, A. Check now. Let us assume that out of 6 people selecting 4 people I selected is A, B, C, D. 4 people I selected is A, B, C, D. Right? A, B, C, D. How many cycles? Because of it is a complete graph. Every combination edge is there. Now one thing I want to say to you. Listen. One thing I want to say to you. Everyone listen. One thing I want to say to you. A, B, C, D. Listen now. A, B, C, D. Remember, you from which vertex you start, it doesn't matter. It is one cycle. Whether you start from A, whether you start from B, it doesn't matter. It is one cycle. Sir, starting A one cycle, starting B one cycle, starting C one cycle. No, that is one cycle only. You start from anywhere, right? You start from anywhere, it doesn't matter, because it is one cycle only. So I started with A only, because whether you start A, whether you start B, whether you start C, finally it's one cycle only. So I think these many cycles are there. But one important question I want to ask you. Listen, one important question I want to ask you. Can you see this? One important question I want to ask you. Can everyone see this? Can everyone see this one? If I go like this, A to B, B to C, C to D, D to A. This is the one cycle, right? If I go like this one, because of it is undirected. If I go like this one, A to D, D to C, C to B. This is, right? These two are one cycle only. Same thing in the reverse order. Same thing, because edges are same edges only there. Same edges are there. At least something should change. Whether you go A to B, B to C, C to D, D to A, or A to D, D to C, right? Whether you come like this, right? Whether you go like this, both are one cycle only. Whether you go clockwise or clockwise, anti-clockwise, that is one cycle only. So what I mean to say is, if anyone is not getting still, What I mean to say is, listen everyone, what I mean to say is A to B, B to C, C to D, D to A. Right? This path is equal to, can you see the reverse? A to D, A to D, D to C, C to B. Is there anything? A to D, I think this one. These two are same. Reverse order check. A, D, C, B, A. A, D, C, B, A. A, D, C, B, A. Next one. Can you see the next one? Right? Next one, if you see A, B, D, C, A. If you see in the reverse order, A, C, D, B, A. A, C, D, B, A. I think these two same. I think these two also same. Check properly. Check properly. Are you getting? So it looks like 3 cycles. It looks like 6 cycles. But same thing if you take clockwise, anti-clockwise, same meaning, because edge is same edges only. If you want, you can verify. Here A to B edge there. Here also A to B edge there. Here B to C edge there. Here also B to C edge there. Something should change. Here C to D edge there. Here also C to D edge there. Here also right, A to D edge there. Here also A to D edge there. Same. So now come here now. Out of 6 vertices selecting for 6C4. Right? Now with the 4 people, how many cycles possible? With the 4 vertices, how many cycles possible? So 6C4 into actually 3 factorial possible. Because of same thing is coming again by 2 half, which will goes to be 6C4 into 3 factorial means 6 by 2. So 3. 6C4 means 6 into 5 by 1 into 2. 6 5s 30 by 2 means 15. 15 into 3 45. 45. Please take care this one. If anyone is getting any doubt, let me know. Remember everyone, with n people, how many cycles possible? With n vertices, how many cycles possible? N minus 1 factorial. Because of same thing is right, clockwise also, anti-clockwise also. N minus 1 factorial by 2, right? 2. N minus 1 factorial by 2. So I will write that also. It will be useful to you. 4 vertices. 4 what, right? I think K4. K4 contain how many cycles? K4 contain how many cycles? 4 minus 1 factorial by 2. K4 contain how many cycles? K4 contain how many? 4 length cycles. I am writing length also. 4 length cycles. K4 contain how many? 4 length cycles. 4 minus 1 factorial by 2. In the similar way, right? Kn contain how many n length cycles? N length cycles. Kn contain how many n length cycles? N minus 1 factorial by 2. If you don't write by 2, same thing you are counting. Anti-clockwise also 1 cycle, anti-clockwise also 1 cycle. No, 2 cycles are different. At least one edge should differ. At least one edge should be differ. At least one edge should be differ. One new edge should come. Same thing you cannot write in another order. Same thing you cannot write in the reverse order. So, right, and listen everyone now. If you start from A, this is 1 cycle. So you cannot say this is one more cycle. You cannot say this. And one more thing. If you start from A, 1 cycle you got, You cannot say that, right? Here B there, here C there, here D there. Sir, I will start from B, I will get one more cycle. You cannot say this. I will start from C, I will get one more cycle. You cannot say this. Starting with A only do, because same thing. When you say cycle, right, you can start from anywhere. When you say cycle, you can start from anywhere. You can start from anywhere. So now come here now. Out of, listen, in the K6, how many 4 length cycles possible? In the K6, how many 4 length cycles possible? Okay, K6, right? K6 means 6 people. 4 length cycles you want means only 4 people. So 6C4 first. Afterwards, now go to one vertex. So 4 people, the 4 vertices, how many cycles possible? Right? 4 minus 1 factorial by 2. Right? Which will goes to 6, right? 6 by 2, 3. So 6C4 into 3, which is going to be 45. If labels are not there, listen, someone is saying that if labels are not there, how to identify? If labels are not there, how to identify? If labels are not there, can I say only one? If labels are not there, can I say only one? How to differentiate? If labels are not there, we cannot differentiate, right? We cannot differentiate anything, we cannot differentiate. Right, fine. So please take care. Accordingly you plan it. I think 8 problems we done. Let's go to 9th problem. Yeah, go to the 9th problem. Let S be an infinite set and S1, S2, Sn be set such that S1 to Sn union is S. Then S is a infinite set, S1 to Sn be set such that S1 union, S2 union and so on, Sn is equal to S. Then what about all these people? Can you help me? Now? Total union is S, which is infinite, means at least one infinite person required. At least one infinite. All may be infinite, it's okay. Few may be infinite, it's okay. But at least one infinite required. At least one of the set Si is infinite. Fine. At least one infinite required. Union of few sets is overall became infinite. That means at least one infinite required. At least one infinite. At least one of the set Si is finite. Maybe, may not. No guarantee. At least one of the person is finite. There is no guarantee. Not more than one of the set Si is finite. No guarantee. Not more than one of the set Si can be infinite. Sometimes 2 people also, no guarantee. So answer is C. Answer is C. Yeah, I think this is a very simple problem. Can you go through, right? In one of the previous paper, this is given, that is the reason I written. The number of elements in the power set P of S of the set S is equal to the number of elements in the power set P of S of the set S is equal to, right? So like this. So everyone listen carefully. How many elements are there inside? 1, 2, 3. 1, 2, 3. I think 2 commas means 3 people. If S contain 3 people, power set of S contain how many? 8 people. It is very simple. It is very simple. Don't worry what is there inside. Don't worry what is there inside. What is there inside? Don't worry. If S contain 3 people, see 2 commas are there. Right? I think to separate 2 people, 1 comma enough. You are using 2 commas means 3 people. Don't worry what is there inside. Inside one element, what is there, you don't care. See, inside pi is there, don't care. Inside 2 people there, don't care. Just see from outside. 3 people are there. 3 people there. Inside the element, what is there, I don't care. How many elements S having? 3 people. If the S contain 3, power set of S contain 8. If you go inside, problem will come. Sir, pi is, how can you say 1 element? Pi is, how can you say 1 element? Remember, outside 2 commas. Outside 2 commas means 3 people. Can you help me now? Outside. Now I want answer from you. How many people are there? Let me check. Can you help me now? How many people? This one contain how many? Don't go inside and don't check. Don't go inside one element and don't check. How many people? How many people are there? Just see commas. Outside commas only check 1. Outside commas only check 2. 3. 3 commas are there. Means 4 people. 3 commas are there. So 4 people. 4 people. S contain 4 people. Power set of S contain how many? 16. Right? Fine. Fine. Is it okay? Just count commas. Don't go inside. If you go inside, you are gone. If you go inside, you are gone. Don't go inside. Inside, if you go, you are gone. Inside, if you go, you are gone. It doesn't matter who is he inside. Inside, who is he doesn't matter. Inside, who is he doesn't matter. Right? Fine. Yeah, in the next class, we will see 10 problems we done. Tomorrow, right? Tomorrow we will try to complete 20 problem. Tomorrow we will complete 20 problem. Tomorrow we will try to complete 20 problem. Today I done 10 problems. Right? Fine. Perfect. Thank you. So if anyone not joined the rank improvement course, right? My suggestion is please go ahead. It will be really useful to you. It will be really useful to you. Please go ahead. Right? Fine. Thank you. See you in the next class. If anyone is not liked, please subscribe and like. Someone is saying, but it is set. Pi comes in power set. Of course, pi will come in every time. See, you no need to bother what exactly it is. How many people, right? 2 power, those many people will come. Maybe in the next problem, Rohit, next problem is that only. We will see in the next class. Rohit, next problem is that only. We will see in the next class. Next problem is that only. We will see that only. In the next class we will see. See, if you want, you can check next problem, that only. See this. This is the next problem. There we will talk. Here we will talk it. We will talk this problem. Right? In the next class, in the tomorrow's class, we will talk. Yeah, thank you so much. See you in the next class. If anyone didn't like, please subscribe and like. Please subscribe and like. If anyone not done, go to hell. If anyone not done, go to hell.